We will have 3 presentations in the morning, starting with Dr. Lothar Bertsch. He is going to talk about the ICAO activities. Then Ivan de l'Epinerie is going to talk about EASA and EASA's mission. And followed will be Mr. de Lupanay by Dr. Rainer Schmidt from DLR. He will give a forecast of future noise development. Then we will have a brief coffee break, and after the coffee break we will have Professor Dr. Lars Enghard from DLR. He's going to talk about the current status of the development of propulsion concepts for the perspectives of flow acoustics. Then Dr. Markus Fischer will be next. He's also from DLR. He's going to talk about the significance of noise research in the context of climate protection. Then we will have a Q&A session. After the Q&A session, we will have a lunch break, then a discussion, and we would like to close at 2 o'clock. And you can once again ask your questions with Slido, www.slido.com, #ICANA. Yesterday, you used Slido, but not that much, which means if you have a question, you can also raise your hand. And yesterday we had the impression that not all the questions submitted via Slido were absolutely clear. Sometimes we did not know what they meant. So simply raise your hand, you will get a microphone, and then you can ask it directly. And on the Slido homepage, you will see 3 dots. You can get the ICANA program and the UNH information. And on the UNH website, you will also find the documentation you can download. You will see all the presentations. Not all of them have been uploaded, but most of them. And we will also have the recordings available for you. Having said that, I would like to move on. I'm looking forward to day 2. And we would like to get started with Dr. Lothar Bertsch, technical expert, studied aerospace engineering in Stuttgart and at Virginia Tech. And we learned a lot about these universities yesterday. He did his doctorate in Braunschweig, has been working with DLR for over 15 years. He had 2 German teams in Göttingen and Aachen, deals with noise prediction and aircraft design, and he's a lecturer at the RWTH Aachen University. And his presentation will focus on ICAO and CAEP. And you're not going to talk about DLR because this will be taken over by the colleagues who will follow. But you will talk about ICAO, which is very important for this conference here. And you're also going to talk about aircraft noise simulation. The floor is now yours.
Thank you very much for the kind introduction. A very nice good morning from my side. I'm really happy that I can talk in front of such a big audience, talking about noise, thinking about lectures at university. Sometimes we are happy if 10 people come up. So I'm really happy to be here today. The subject matter today is several goals, very different goals. I would like to explain to you how I understood that ICAO works, the International Aviation Organization. For civil aviation, there is a technical committee that exclusively deals with environmental issues. I would like to talk about this, and I have 2 more points. I would like to show you how DLR is incorporated in that. And another technical point, I would like to explain how we support CAEP, also with the simulations that we do in Göttingen. So I brought some technical points also. I mentioned it before. This is the structure of my talk. I would like to talk about ICAO and CAEP. With CAEP, I will talk about the flight noise activities, the DLR activities in that context, and the second part will deal with noise simulation, because particularly in this context, that's really important. As with our results, we can really contribute to the work of ICAO. We have a beautiful exchange with them. And finally, I will make a short summary and conclusion. As the slides are distributed, I developed an appendix with all the nominated technical experts from the DLR in ICAO, so you maybe find contact data for a certain expert if you have a certain subject to discuss. All right, let me start. It all starts at the top with the United Nations. The United Nations organization runs what they call specialized agencies. That's kind of an authority for different activities and tasks. One example is the WHO. You all know what that is. And at this level, similar, the ICAO is organized for aviation. It's composed, or let me start the other way around. It was founded in 1944 already. 193 nations are members of ICAO, and the main task is diplomacy and cooperation in civil aviation and its promotion, and all is based on the so-called Chicago Convention. That was the founding document. And we heard several times already that there are the annex amendments for certification, and that's part of this document. At this point, it's highly important, and on their website, this is really underlined. The proposals submitted by ICAO have to be ratified by the member states. It's only a proposal system, so no rules or laws are issued. Sometimes they face counter winds, and people ask, what are you doing here? So they really make it very clear they only submit proposals. Now, let me talk about the structure of ICAO. There are 3 pillars. First, we have the assembly. That's where the member states meet. And then there is a council and the secretariat. Now, what does the assembly do? It's composed of all 193 member states. It's really a very large assembly which reviews and overviews all ICAO activities, including the budget, which is highly interesting and important. What they do, they set priorities for the work within ICAO, and finally, they ratify everything. That is, if there is a new proposal, the assembly decides whether this proposal will be accepted and approved. And the second pillar is the council. These are elected members of the 193 totally. 36 members are elected. I haven't found it out clearly. They say it's limited to politicians. You have to fulfill certain criteria. Can't be technical experts like me. Rather politicians. That's the council, and the council coordinates everything. And all this is supported by the secretariat. I show you the workflow in a minute. I tried to show you a graph on how the work is organized. This is, again, the picture of the 3 pillars of ICAO. The council establishes technical committees, the so-called TCs, that would carry out the technical work, the studies, as it were. And all this is organized by the assembly. The assembly determines tasks and hands it over to the council. And they would specify it further, like they demand studies that processes such a technical committee. The technical committees would elaborate recommendations, they issue reports, and the reports then go back to the council. They look at it and maybe ask additional questions, send it back to the technical committees, and then finally on that basis they develop the proposals for the assembly. The assembly only meets every 3 years, and then they ratify the proposals. And the big goal is that you come to an amendment of the Chicago Convention, as you see here on the left-hand side. And down here you can see the secretariat. The secretariat documents everything, administers, organizes all the processes, etc. That's their task. I mentioned before that tasks are assigned. Look here. I mentioned the technical committees before. One is the CAEP, C-A-E-P. It's a technical committee that exclusively concentrates on environmental protection. And they really look at the 3 goals determined by ICAO. And you see them listed here. Either it's a limitation or a reduction that has climate impact, that has an impact on local air quality, and also they want to reduce aircraft noise. These are the 3 most important goals mentioned in the Articles of Association of ICAO, and that's what CAEP, the CAEP, deals with. What do they do in concrete terms? They conduct studies, they develop proposals for new laws, they issue recommendations. And that's highly interesting, and we, as technical experts and participants, regard that very important. It's a very comprehensive assessment. They start with the individual plane and then look into larger scenarios like big airports or global scenarios even. What measures are looked at? It's the typical examples here: aircraft technology, new drafts, new designs, new engines, operational improvements, approach and departure processes. Then we heard the catchword yesterday, SAF, Sustainable Aviation Fuels. That's a big point. And then the COSIA measures, the CO2 trade. I didn't know that before. It's really a large group, 600 participants in CAEP. At least that was the case in 2021. 31 are members with their nominated technical experts. And I have the pleasure to be one of the technical experts. And the number of the technical experts per member is not limited. Like from the DLR, it's 12 colleagues, male unfortunately only, no female. Then among the 600 we have observers. They have not that strong rights as full members, but they may also nominate experts, so you come to a total of 600 participants. It goes further. We have not managed to have the full picture yet. The CAEP breaks down in further structures. There are different disciplines and tasks, and for that purpose we have what we call working groups within CAEP, and the members of CAEP would register for such a working group and would also assign their technical experts to these groups. Here you see the most important groups that are relevant for us. We have the WG1, noise. I sit in this working group. Then we have working group 2, operations, 3, emissions, 4, that's climate, mainly CO2 trade. And then I'm also a member, the MDG, that's the Modeling and Database Group. Here, modeling approaches are not developed but approved of, like with what software can you calculate noise, ISO contours, and also databases are maintained. They are large databases with noise levels of the existing fleet. And today we want to talk about aircraft noise, and I wanted to show you one example that is dealt with by CAEP. You have seen that graph before, maybe presented in different forms. One of the annexes of the Chicago Convention regulates the aircraft noise certification of civil aircrafts. You have the EPNDB. You can see the values are strange, very high. That's the total, the linear total of certified locations. locations. If you had 90 at every location, it would be 270. And there you can see the maximum departure noise total. And you can see how loud it may be. And CAEP has been doing that for a long time. You can see from 1973, the first limits were determined. And then it became stricter and stricter. And today we are at chapter 14. If you look into chapter 2 and 14 and compare that, you will find the 30 dB that were mentioned yesterday several times. What activities do we have currently at CAEP? Of course, aircraft noise modeling, that would be the first point. Then noise trends are looked at. That is how will the future develop. Then technology goals are determined. And what I also like is community engagement. That's one point as well. So they want to communicate with the affected population. Then new aircraft concepts, air taxis and drones are to be mentioned here. And then number 5, the standards for certification of the modern supersonic transport aircrafts. We talked about that yesterday. And here you see the second part of the presentation, the contribution of DLR to CAEP. If we compare the points, it's always on one line. For the first point, the aircraft noise modeling. Here, with our noise forecast, we make a contribution. I brought some slides on that as well. And for the other subjects, we also intensively deal with the subject matter. And in the following presentations of my DLR colleagues, you find more of these points described in detail. Now, let me come to the second part of my talk. I would like to show you in concrete terms how DLR supports CAEP. Sorry for that slide. I still have a formula here, but I think it's very illustrating. This is the permanent noise level. And I don't want to go into detail here. You can have a look at the ICAO balanced approach measures that are derived. These are measures by ICAO how to reduce aircraft noise. And what you also see in this slide, I don't want to read out everything. If you want to come to a total reduction, you have to do everything at the same time. At the source, you have to do something in the operations, in the flight path, and the small g, that's a punish factor for the time when such a flight movement happens. So here the planning might improve the situation. And the balance approach means that you do that all at the same time. And if you look at the formula, you see that it makes sense. How do we do that with the DLR? The ICAO balanced approach shall be completely looked at. And for that purpose, we have the multi-level simulation. So let's see whether the laser pointer works. Let me start at the top. That's level 1, the component level. Yesterday we heard about many technological measures. Porous materials in the landing gears, the rear flaps, acoustic lining with the engines, etc. All that would belong under level 1 component level. So we have experiments or calculations at higher levels. We have carried out simulations and we install it on the aircraft in order to make a conclusion how the technology installed in the aircraft would have an effect. And you would not only do that with an individual aircraft, you want to do more, want to do it for a whole scenario. That would be level 3. So I have to change again. And now you see more pictures on the left-hand side top. You see where level 1 could be, where the data would come from higher value simulation or from an experiment. Level 2, that's very small. This is just an indication how it would be. That would be a simulation of an approach path, of a trajectory, when the flaps are ejected and what the altitude development is. All this is also incorporated And the individual technology then is shown in operation. The graph that I show you now shows you the route configuration and at what time of the day what aircrafts start or land, and then you can put that together like a total contour. And with this approach, we really help ICAO to develop all these data. And I would like to share with you a few more slides, because the link between the individual technology till the impact in a certain scenario is extremely important. And for that reason, I would like to explain further how we do that. It is highly important to see the entire aircraft with all the sources of noise in operation. Here we have the catchword emission. What happens at the source? I mean, it's not really important for the population. For them, it's only important what they hear on the ground. So you have to propagate it down to the ground. And we have to look into different technologies, engines, etc., everything here. How do we do that? On the right-hand side, you see a graph with the main sources of noise for the aircraft and for the engine. We all incorporate them, including the respective data, engine operation, revolution number, speed, flaps, geometry of flaps, etc. All this is taken up, and that's the important catchword, components. We do it per component. So you present the aircraft as a total of all the individual contributors. And the second point is the parametrical approach. Independence of the geometry of the aircraft and the aircraft operation, the forecast level has to change. If I start the thrust, we really have to see the impact on all the other components and the total noise. What's the result? We can determine a detailed emission analysis in order to understand sources better. You run through the individual components. You see how they radiate spectrally, in what direction the source radiates. And all this is then propagated to the ground, and you have the emission. And you can do that on the component level. Landing gears could fly separately to see what it produces on the ground. And you can do that with single observers. You have seen the certification levels here. These are only individual points. On the right-hand side, there is a noise contour. There you see that it changes a lot along such a trajectory. And this is what models also can do and have to do. And the last point, all standard noise descriptors need to be determined as a result. The EPNL can be determined in SEL or LAX. An A evaluation, not an A, but a component-wise evaluation as a function of time, etc. All this can be calculated. Now let's go through that a bit more quickly. I mentioned it already before, mixed fidelity. Let me illustrate that with the help of an example. We saw it yesterday, a blended wing body. Here in color, you see the different sources of noise. It's about shielding or reflection. It's from higher value simulation results, and we use that further. Here you can see in green, for example, the landing gear position is shown, and there can also be a reflection, and then it becomes louder. In the colors you see that can turn red. That's the dB change per source because of the presence of such a aircraft. What's highly important, and we could have a whole lecture on that, that's a big goal, and with that I come to the end. Of course, you need to know uncertainties as well. If you look at the ISO contour surface that we calculated, we as scientists want to know how well that matches with reality. So a lot of research is ongoing in that field, and we would like to make that part of the ICAO discussion. There are first studies of NASA of supersonic aircrafts. They also determine a standard deviation of such a forecast level, and we are working on that. We would like to understand and see how good our results are that we calculated and simulated. Here, a more colorful picture. This is meant to show you a start and landing. It's a simulation. And this is the parametrical component level assessment. You see here, once the aircraft passes by, the noise changes during the operation. The altitude changes, the thrust changes, the speed changes. When you land, you open the flaps and position the landing gear. So you have to really consider all that. All these details are so important. Finally, I have one concrete example that we also have discussed in ICAO. It is a cooperation with EASA. What we did here is 3 generations of engines that we studied, installed them or simulated them for overflight. Don't want to talk about the table, maybe only the graph is important right now. You can see the cumulative EP and dB. So that's the total of these 3 locations. And in the course of the years, you can see the evolution of engine technology, and you see that the noise level goes down, the red curve. In 2010, we had the first GTF engines that we started, and that was 70 dB. And it goes down. There is a bending point, and with the next generation then, we expect that maybe there will be 6 more dB that we can reduce, so distributed over all measurement points. So it would not be 6, but 2 at every location, measurement location. So this is only one example, and there are many more considerations and research activities, especially in the DLR, how I can further reduce noise and what kind of technologies I have in my portfolio. And I'm so happy to see that again later on in the presentations of my colleagues, particularly the flow sounds. Markus Fischer will talk about that. Engine, Lars Enghart will talk about that, and new aircraft designs. Rainer Schmidt will talk about it, and also Markus Fischer. All right. A summary, maybe 2 more sentences, and then we are through. What I wanted to do today was to explain how the ICAO is organized, what CAEP is, what it does, what activities we do in the area of aviation noise, and how the DLR makes its contributions. And finally, at the technical level, how can we support the work of ICAO and CAEP as DLR in the technical field? That's the end of my presentation. Thank you very much. Thank you, Dr. Bertsch, and thank you very much for the time discipline. I stole a bit of your time in the introduction round. One question of understanding from Slido. How is that difference between Chapter 4 and Chapter 14? Why doesn't it just go further in the numbering, this ICAO chapters?
Why, oder Lars?
Herr Professor Enghart.
Das wüsste ich gar nicht.
There's no microphone. I can't hear it. It's an ongoing numbering of the chapters that are added to the Chicago Convention. And now the microphone is brought to you. So I need not just repeat what you do. This leap was not intended. Probably they could have done that in Chapter 5. It's a very comprehensive report, and for this new regulation, they put it into Chapter 14. It slipped there. That's a simple explanation. There is no further explanation for that in the chapter of the document that documents everything. So there is no leap from 10 to 14 or anything like that. No, it's a continuous process, but it's just presented at a different place. No microphone. I don't hear anything because the microphone is not used. So thank you very much. Thank you very much to you, Dr. Bertsch. We have the question round together later on, and should you think of additional questions about ICAO, you can collect them under Slido, and we can talk about them later on.